The 737 electrical system generates electrical energy from any airplane systems. The system generates alternating current, direct current, and standby power. Primary AC electrical power is supplied by two engine-driven integrated drive generators, or IDGs. The IDGs are lubricated and cooled by a self-contained oil system. The IDGs supply power directly to the AC transfer buses. Each IDG is controlled by a generator circuit breaker, or GCB. The transfer buses are connected by a tie bus and two bus tie breakers, or BTBs. The AC transfer buses supply power to the remaining AC buses and the transformer rectifiers, or TRs. The TRs are the primary source of power to the DC buses. The main battery energizes the hot battery and the switched hot battery buses when AC power is not available. It can also supply emergency power for the battery bus and the AC and DC standby buses. The auxiliary battery is used only as an emergency power source for the standby power system. The battery chargers maintain the battery's charge. The main battery charger is also the normal source of power for the hot battery and switched hot battery buses. The APU operates a generator which can supply all necessary electrical loads in flight or on the ground. External AC power can also be used on the ground. It is connected to the airplane through a receptacle on the lower right side of the fuselage. The ground service switch lets you connect external power to the ground service buses from the forward flight attendant panel in the cabin. There are two basic rules of operation in the 737 electrical system. 1. AC power sources cannot be operated in parallel. Only one source of AC power, an IDG, the APU generator, or ground power can be connected to a transfer bus at a time. 2. If a second power source is connected to a transfer bus, the first source is automatically disconnected. Most of the flight deck electrical controls and indicators are on the forward overhead panel. They are the AC and DC metering panel, the generator drive and standby power panel, and ground power and bus switching panels. The P6 and P18 circuit breaker panels are found behind the first officer's and captain's seats. The AC power system is made up of transfer buses, main buses, galley buses, an AC standby bus, and ground service buses. The transfer buses are connected by a tie bus and bus tie breaker system. If two power sources are connected, the bus tie breakers open to prevent parallel operation of the generators. If only one power source energizes the tie bus, The tie breakers close to supply power to the two transfer buses. The sources of AC power are ground power, the APU generator, and the engine-driven IDGs. Let's look at more of the electrical system. To start the pre-flight, move the battery switch to on. These annunciator lights tell you about transfer bus status. The transfer bus off light shows that the related transfer bus is not energized. The source off light, as shown here, tells you no power source is selected to energize the transfer bus. The light can also illuminate when a generator switch is moved to on and the related generator does not connect and supply power to the bus. Or if a connected power source is replaced by a different source. Under these two conditions, the transfer bus does stay energized. The generator off bus light tells you the transfer bus is not supplied with power from the related IDG. The APU generator off bus light shows the APU generator is available, but does not supply power to a bus. The light extinguishes when the APU generator is connected to a bus. The ground power available light illuminates when ground power of good quality is connected to the airplane. The light does not extinguish after ground power is connected to a bus. To connect a power source to the AC buses, you must momentarily move a power switch to the on position. Connect ground power. When ground power is connected, the transfer bus off and source off lights extinguish. The two transfer buses are energized through the tie bus. The APU is running, so move the APU generator number 1 switch to on. The APU generator disconnects ground power from the tie bus. The source off light illuminates because the manually selected source has been automatically disconnected. Move the other APU generator switch to on and we'll remove ground power. Engine number 2 is now running. Move the generator number 2 switch to on. The generator off bus light extinguishes, and the bus tie breaker opens. The number 2 IDG supplies power to transfer bus 2. When an IDG supplies power to one transfer bus, the other continues to be energized by the APU generator or ground power if it is connected to the system. The APU generator or ground power can energize one or two transfer buses, but they cannot be connected to any part of the electrical system at the same time. Engine number 1 is now running. Connect the generator. The number 1 IDG now supplies power to transfer bus 1. The APU generator off bus light illuminates because the APU generator is no longer connected to a bus. The AC electrical meters show voltage, frequency, and amperage of the source selected by the AC meter selector. The cabin utility and in-flight entertainment passenger seat IFE pass power switches control two sub-buses off the AC transfer buses. The buses control galley power, passenger convenience items, and in-flight entertainment systems. The switches are normally put to on during pre-flight. If the APU continues to supply power to the transfer buses after takeoff, and then fails or is shut down, the IDGs automatically connect to the buses. The automatic generator online feature is available only in flight, only one time per flight, and only under these conditions. During flight, if only one power source is available, the electrical system automatically removes power to some buses to decrease the total electrical load. This is referred to as load shedding. The galley buses are de-energized first. If the load continues to be greater than the available electrical power, the main AC buses are de-energized one at a time until the load is less than the system limit. Later, if more power becomes available, some or all of the buses are automatically energized again. During taxi-in, you can connect the APU generator after the APU generator off bus light illuminates. Move the APU generator switches to on. The APU generator now supplies power to the transfer buses. The engines can be shut down normally when the airplane is at the gate. The 737 uses 3 transformer rectifiers to supply 28-volt DC power. The TRs change 115-volt AC from the transfer buses into 28-volt DC for use by the DC buses. TR1 is supplied power by transfer bus 1 and is the normal power source for DC bus 1. TR2 is supplied by transfer bus 2 and is the normal source for DC bus 2. Transfer bus 2 is the normal power source for TR3, but transfer bus 1 can also be used. TR3 is an auxiliary source of DC power if TR1 or 2 fails, and is also the normal source of power for the battery bus. If a TR fails, the remaining TRs can supply power for the total DC load. The DC buses are connected by a cross-bus tie relay. The relay opens automatically when the glide slope is captured during an ILS approach. The relay opens to isolate the navigation receivers and flight control computers. This prevents the removal of all approach information because of only one electrical failure. The relay also opens when the bus transfer switch is moved to off. The bus transfer switch is discussed later in this lesson. If normal sources of power to the DC buses fail, the emergency source of DC power is the batteries. 2 24-volt nickel-cadmium batteries are installed. Battery power can energize the 2 standby buses, the battery bus, the hot battery bus, and the switched hot battery bus. The hot battery bus is always connected to battery power. Its components operate as long as battery voltage is above a minimum value. Power to the switched hot battery bus is controlled by the battery switch. The battery switch and battery operations are discussed as part of the standby power system. The automatic battery charger restores and maintains full battery voltage. The battery charger is supplied power from AC ground service bus 2 when a source of AC power is available. A different battery charger for the auxiliary battery is supplied power by AC ground service bus 1. The controls and indicators for the DC system are on the AC and DC metering panel. The DC electrical meters show voltage and amperage of the source selected by the DC meter selector. The maintenance switch is used by maintenance personnel to do electrical system tests. The standby power system supplies AC and DC power to important electrical components when normal AC power is not available from the engine or APU generators. The standby power system uses the batteries and a static inverter to supply power to these buses. With no other power source available, the batteries can supply power for a minimum of 60 minutes. Battery power is the emergency source of power for the DC standby bus, the battery bus, and the static inverter. The static inverter changes 24-volt DC battery power to 115-volt AC power for the AC standby bus. There are two controls related to the standby power system. Let's look at the standby power switch first. The standby power switch has 3 positions and is normally in the auto position with the guard closed. In auto, the standby buses and the battery bus are supplied power from their normal power sources. But if all sources of AC power are removed, the standby power control unit automatically changes the standby system to battery power. The power change can occur on the ground or in the air. Now move the standby power switch to the off position. In the off position, the AC and DC standby buses and the battery bus are disconnected from all power sources, normal or battery. The standby power off light illuminates when power is removed from one or more of these buses. Move the standby power switch to the battery position. Battery power is now manually connected to the standby power system. Move the standby power switch back to auto. The battery switch is the other standby power control. The on position always energizes the switched hot battery bus and the other circuits to automatically change to battery power if normal power is not available. Move the battery switch to off. All power is now removed from the standby power system and the switched hot battery bus. The standby buses operate these important components. Touch each menu item for more information. The bus transfer switch is normally in the auto position. If a failure occurs in one generator, the related transfer bus is automatically connected to an available generator. The off position is used during non-normal operations. When the switch is moved to off, the bus tie breakers and the cross bus tie relay open to isolate the two sides of the electrical system. In this example, transfer bus 1 and its related buses are all de-energized. On the ground or in flight, if the APU generator is the only available power source, the off position arms each bus tiebreaker to open if its related APU generator switch is set to off. In this example, transfer bus 2 and its related buses are de-energized by the number 2 APU generator switch. If a system malfunction disconnects the engine-driven generators from the transfer buses, the autopilot disengages and cannot be engaged until a generator is available. The master caution lights and the electrical system annunciator light illuminate. The remaining system lights are related to other de-energized items. The transfer bus off, source off, and generator off bus lights for the two generators also illuminate. You can try to immediately connect the generators again. If the two source off lights stay illuminated, it is first necessary to prevent high electrical loads before a generator is connected to the system. Move the bus transfer switch to off. Turn off the electric hydraulic pumps. If it is available, start the APU. With the bus transfer switch in off, connect the APU generator to only Move the APU generator number 1 switch to on. Now, move the bus transfer switch to auto. This energizes transfer bus 2. Move the APU generator number 2 switch to on to extinguish the source off light. Turn on the electric hydraulic pumps one at a time. If the two source off lights do not extinguish, battery power is the only power source for the standby power system. Land at the nearest suitable airport. If a malfunction causes only one generator to disconnect, the temporary change in power can cause the autopilot to disengage. It can be engaged again after power to the transfer buses is stable. As before, the master caution and related system annunciator lights illuminate. The related source off and generator off bus lights illuminate. Try to connect generator number 1. The generator connected normally. If the generator does not connect and the source off light stays illuminated, you can start the APU and connect its generator. If a transfer bus off light illuminates, the related bus is de-energized. You can follow the same steps as for a source off light to get power to the bus again. If the standby power off light illuminates, then power is not available to some part of the standby power system. Move the standby power switch to the battery position. The light extinguishes and the battery power now supplies the standby system. The generator drive light illuminates when an IDG has low oil pressure or the engine is not running. The generator drive disconnect switch lets you disconnect an IDG from its engine during a non-normal situation. Disconnect IDG number 1. After an IDG is disconnected in flight, it can only be connected again by a ground maintenance person. The battery discharge light illuminates when the battery switch is on and the battery discharge rate is large. During an APU start on battery power, it is normal for the light to illuminate for a short time and then extinguish. The TR unit light illuminates when a TR fails on the ground. During flight, it illuminates when a failure occurs in TR1 or TR2 and TR3. The electrical light tells you there is a failure in the DC or standby power system. This light illuminates only on the ground.